Hi, Science 20s. This is part 3 of naming ionic compounds. Now we're going to look at multivalent ionic compounds. Those are metals that have more than one possible charge. So if we take a look in your periodic table and you find iron, element number 26, you will see that iron has two charges listed. Iron can be iron 3. Oh, and I flipped the page. Iron can be iron 3, or iron can also be iron 2. The top one is the most common. If I don't say anything in the question, that is the charge I mean. This is also true for things like copper. Copper can be copper 2 ions or copper 1 ions, and there are many, many ones like this. In order to tell the difference in a question, we will use Roman numerals and brackets the same way we did in Science 10. And the nice thing about your Science 20 data booklet is they actually show you the Roman numerals right here on the page. So let's do some practice. Before we can do this, we have to be able to know our Roman numerals. So 1 is I, 2 is II, 2 ones, 3 is III, 3 ones. If we skip 4 for a second, 5 is a V, which means 4 makes sense. 4 is IV, 1 before 5. 6 is VI, 1 after 5 would be 6. So you learned these already in Science 10. I still hope you know counting 1 to 6 in Roman numerals. What I would like to do is show you how are we going to go from the compounds, the written formulas, to naming these. So first thing I want you to do is, can you find your Fe and Cl and put your finger on them for me, please, on your periodic table? What I want you to notice is when you find Fe has more than one possible charge. Because it has more than one possible charge, I want us to go to the anion instead. Let's look at chlorine instead. Chlorine, when we look it up, has a charge of -1. Now, I have 3 chlorines, therefore, I've got 3 chlorines, each with a -1 charge. So when I add up all the charges on all the chlorines, we add up to -3. Therefore, since this has to add up to a net charge of 0, if chlorines add up to a total of -3 and we only have one iron, iron must have a charge of +3. Again, I'm going to go through that one more time. Since iron has more than one possible charge in the periodic table, we're going to go and look up chlorine. Chlorine has a charge of -1, but I have 3 chlorines, so that means I'm going to have 3 -1 charges. The total charge for chlorine then is going to be -3, which means the total charge in iron to balance this out has to be +3. We are going to call this iron 3 with Roman numerals and brackets, chloride. Okay, let's do a second example. Again, we have iron. Iron has more than one possible charge, so we are going to go look up chlorine. Chlorine always has a -1 charge. Since I have 2 chlorines, I have 2 -1 charges, which means the chlorine adds up to a total of -2. Since I only have one iron, what balances out -2? That would be +2. So this iron must have a charge of iron 2 chloride. Just got a little ahead of myself. Okay, let's clear this page. Let's flip pages. And let's do 2 more examples, you and me, and then I'm going to have you push pause and do these 3 examples by yourself before you check your work. So we're going to look up Ni, which is nickel. Nickel has more than one possible charge, so we're going to go to the chlorine. Chlorine has a charge of -1. I have 2 of them, so that's going to be another -1. Chlorine adds up to -2. Since the right-hand side adds up to -2, the metal side has to add up to +2. And since I only have one nickel, that means nickel is going to be +2. So we're going to call this nickel 2 chloride. Again, everybody find Hg. Hg is mercury. Mercury has more than one possible charge. So we're going to go to the nitrogen. Nitrogen is always -3. Since nitrogen will add up to -3, we need the mercury to add up to +3. And because I have 3 mercuries, that means every single individual mercury will add up to +1. Again, I'm going to go through that one again. Nitrogen is -3, so the total here is -3. That means the total of all the mercury has to be +3 to balance. But because I have 3 mercuries, each individual mercury is going to add up to only +1. So we are going to call this mercury 1 nitride. Can you pause your video and go try these 3 examples, please, for yourself? Okay, I looked up Ti. Titanium has more than one possible charge. So I'm going to look up Cr2O7 instead. This is dichromate. Dichromate has a charge of -2, but you'll notice I have 2 dichromates, so I'm going to have another -2. That means all the dichromate adds up to -4. I have 1 titanium, so what adds to -4 to make it equal 0? Well, that's going to be +4. So we are going to call this titanium 4 dichromate. Now, AgF is a little trickier. When you look up Ag, and I do this to make sure you're putting your fingers on the periodic table. When you look up Ag, Ag is silver. It only has one possible charge. Therefore, I don't use Roman numerals. I don't use brackets. I just name this as I always have, silver fluoride. This is a binary ionic compound. This is the part 1 video. Again, please don't get caught. Don't turn your brains off. I throw this in on purpose so that you make sure you're thinking all the way through. And our last example, and my pen has turned off, so I'm going to trick it. Our last example is we have copper. Copper has more than one possible charge, so we're going to look up PO4 instead. Phosphate is -3. I have 2 of them, so that's 2 -3s. So this adds up to -6, which means all of copper has to add up to +6. But I have 3 coppers, so that means every individual copper is going to be a +2. 2, 4, 6. So I'm going to call it copper 2 phosphate. And again, I'm going to clear my screen. And we're going to go to our next slide. Like always, we have to also be able to work backwards. How do I go from words to symbols? Well, this is even easier. 95% of the time, they're going to help us out. So if I take a look here, they called it iron 2 oxide. This 2 tells me the charge on iron is 2. Iron 2. Oxygen, when I look it up, is -2. These guys balance a net charge of 0, so we're just going to write this as FeO. It already balances. Gold, 1, is going to be +1. Sulfide is sulfur. That's a -2. So I'm going to need more golds. 1, 2 golds. So this is going to be AU2F. Copper. Now, if I look up copper, copper has more than one charge. If they do not tell me the charge, you always assume it's the first one listed. So since copper first charge is 2 positive, that's what we're talking about. Nitrate is -1 because 8 polyatomic. So we're going to need 2 of these to balance out. So we are going to write this as Cu bracket NO3 bracket 2 because I needed 2 of the full nitrate. Last one, nickel 3, which means nickel has a 3 positive charge. Carbonate is -2. Again, they're not going to balance. I need another carbonate. Now I need another nickel. Now I need another carbonate. +6, -6. Now they add up to a net charge of 0. So we are going to write this as Ni2 for 2 nickels, bracket CO3, 3 for 3 separate carbonates. I'm going to clear this off. And I'm going to have you try these 5. Pause your video and then check your answers with me, pretty please. So chromium 2, positive 2. Cyanide is negative 1. So I'm going to need 2 cyanides. I'm going to write this as Cr bracket Cn, and I needed 2 cyanides. Tin 4, positive 4. Bromide, negative 1. I'm going to need 4 of those. To balance out the charge, we're going to write this as SnBr4. Manganese did not tell us the charge, so that means we have to look up in our sheet. The first one listed is positive 2. Oxygen is always negative 2, so they already are balanced. MnO. Lead 2, positive 2. Hydroxide is negative 1. We're going to need 2 hydroxides. So we are going to write this Pb bracket OH bracket 2 to make sure we have 2 of the full hydroxide. Last one, gold 1. Nitride is negative 3 because that's nitrogen. So we're going to need another gold. We're going to need another gold. So I have 3 golds. So we're going to write this as AU3N. Hope you found this informative and that you're starting to get lots of these right. Good luck on the worksheet.